Hello everyone. Today I would like to talk about the reaction mechanism and the molecularity of the chemical reaction. This is under chemical kinetics. I'm Dr. Buddhika Liyanige. So without further delay, let's go and find out the concepts. What is reaction mechanism? A reaction mechanism is step-by-step sequence of elementary reactions. You can see here a balanced chemical equation given. The reactant is hydrogen peroxide, products are water plus oxygen. This equation is balanced. By looking at this equation, you can see the reactant and the products. However, this is not a single step reaction. This chemical reaction is undergoing through another two steps. These two steps we call elementary steps or elementary reactions. These elementary reactions together we call reaction mechanism. Why we need reaction mechanism? Reaction mechanism provides a detailed explanation of how reactants transform into products, and also it gives information about what are the intermediates and what are the transition states. Now let's take an example. The chemical equation given here, 2 moles of nitrogen dioxide produce 2 moles of nitrogen monoxide plus oxygen. This is the balanced chemical equation. We can see only the reactants and the products. However, the reaction mechanism is two elementary steps, step 1 and step 2. So you can see step number 1 is slow step number 2 is fast step. How we can identify the overall reaction using the mechanism? You need to add all the elementary steps together, step 1 plus step 2. Cancel the similar chemical species appeared in both sides. Here NO3 in reactant side and the product side. After we cancel and then clean up the equation, you can get balanced chemical equation. This is the overall equation for this reaction mechanism. Now let's summarize. The sum of the elementary steps must give the overall balanced equation. And what are the intermediates? The NO3 is the intermediate here. Intermediates does not appear in the overall reaction, but intermediate appear in the elementary steps inside the reaction mechanism. And also it appear in a early elementary step and disappear in the later elementary step. So that's how we can identify the intermediates in a reaction mechanism. What is the rate determining step? In a reaction mechanism that has more than one elementary steps, like the mechanism we discussed in the previous slide, the rate law for the overall mechanism depends on the rate determining step. What is the rate determining step? Rate determining step is the slowest step in the reaction mechanism. Let's take the same example. Step number 1 is the slow step and step number 2 is the fast step. Then the slow step determines the rate of the overall process. So our rate determining step is 2 NO2 molecules combine to form NO3 plus NO. Let's apply the concepts we learned so far. For example, the reaction between NO2 and carbon monoxide to produce NO and CO2 is believed to occur via two steps. That means two elementary steps. The experimental rate law is rate is equal rate constant K times NO2 concentration squared. These are the elementary steps given for you. Now part A, write the equation for the overall reaction. As we learned in the previous slide, the overall reaction is addition of all the elementary steps together. Here two elementary steps, step 1 plus step 2. This is our overall reaction. Part B, identify the intermediate. Intermediate does not appear in the overall reaction. However, it should appear in the reaction mechanism. So you can clearly see NO3 appeared in the step number 1, the first elementary step, and it disappeared in the step number 2. So NO3 should be our intermediate in this reaction mechanism. Part C. What can you say about the relative rates of step 1 and step 2? You can see the experimental rate law is given. Rate is equal K times concentration of NO2 square. So normally we are writing the rate expressions in terms of reactants. So which step? Step 1 or step 2 containing 2 NO2 molecules? Step 1. That means step 1 should be our rate determining step, or another way, slower step. Step 1 should be the slower step and it should be the rate determining step in this reaction mechanism. Let's talk about the molecularity. The molecularity of the chemical reaction refers to the number of reactant species. These reactant species can be atoms or the ions. What are the types of molecularity? Molecularity can be unimolecular, bimolecular, or termolecular. Unimolecular reactions, a single reactant involved in this reaction. For example, decomposition of ozone. The ozone is one molecule, one reactant decomposed into diatomic oxygen plus atomic oxygen. Bimolecular reaction. Bi means two reactant species involved in the reaction. Example like hydrogen and iodine combine to form 2 moles of Hi, hydrogen iodide. Two species, that is bimolecular reaction. Termolecular. Ter means 3 reactant molecules collide to give the products like 2 moles of NO plus oxygen. So here 2 plus 1, 3 molecules, termolecular reaction. Let's find the molecularity of these examples. First one, cyclopropane gives propene. Only one reactant molecule is involved here. This should be unimolecular reaction. Second one, 2 moles of NO plus 1 O2. 2 molecules or 3 molecules or 3 moles involved here as reactants. Then it should be termolecular reaction. Next one, nitrogen monoxide 1 molecule plus 1 ozone. There are 2 total molecules in the reactant side. This is bimolecular reaction. And the last one, dinitrogen pentoxide decomposed into NO2 plus NO3. Only one species in the reactant side. This should be unimolecular reaction. I hope you all understand what is the reaction mechanism and what is the rate determining step and the molecularity of the chemical reactions. Thank you all for watching.